So what I'm going to do with this problem, like I've been doing, is to put it in the context of make a table of values to help frame where you're going to be going with the graph. And then we'll talk about how to draw the graph from there. Since the borders are relatively large numbers, I'm just going to stick with 0 through 6 as my x values. So 0, 1, 2, 3, 4, 5, and 6. That should be enough points to give me a good idea where I'm going. Now, these won't be given in the problem. It'll be up to you to come up with these data points. There's where I'm ultimately going to draw my graph. Okay, well, let's see. If x is 0, is that the first equation or the second equation? Yeah, it's less than 3, or it's equal to 3. So I'll use that first one. So that means it's 0 minus 2 or negative 2. And I'm going to go ahead, I'm going to plot the points as I come up with them in order to keep showing how they translate over. The next example, we'll try to do it without the table of values to see if you have enough of the idea down where you don't need that. But never be afraid, whenever there's a problem that has the word graph, never be afraid to make a table of values. Even when I was doing calculus, once in a while, if I wasn't sure what the graph was going to look like, I take out the calculator, knock out a couple of numbers in a table, and say, okay, this gives me some points to play with at least. Let's see, if I use that x is 1, is that the first or second rule? Still in the first. Okay. So 1 minus 2 is negative 1. 2 is still going to be in the first rule. What about 3? Yeah, because it's equal to 3. So I'm still in that first rule. So let's plot those guys. So at x is 0, I have negative 2. X is 1, I have y is negative 1. 2 comma 0. 3 comma 1.
It's 4 and 4.
If x is greater than 3, then the outputs are all 4. Well, let's see. Is 4 greater than 3?
Oh, wait. Yeah.
Mm-hmm. Is 5 greater than 3? Yeah. So 6.
Yeah.
So at 4, 5, 6. If I look at my graph, I've got this line down here. I've got this line up here. I just need to figure out what to do here at 3 to connect it up. Because I have this gap unaccounted for. So do I continue this line up at an angle, or do I bring this line over to connect that so that I can say every x is accounted for? Here's kind of the hint. The border is 3, but this is strictly greater than. So it doesn't include the point 3 itself. This one goes all the way up to 3 and stops once it passes the 3. And that's kind of your hint. It should look like that. This is all happening right here at 3. So at the cutoff point between one rule and the next, the important idea is to see, well, where is the open dot? Where's the closed dot? There's kind of your hint. It says x is strictly greater than 3.
Okay.
So that means it doesn't include 3. It includes everything else. So this line comes all the way up to 3 and then stops before it gets there. Yeah.
How do you figure out where the arrows are going?
Arrows always continue off the graph. Well, this one goes off to the left. This one goes off to the right.
say if you're, say, you know where that arrow to the down, yeah, say it won't ever go to the left, it won't ever go to the left, it won't ever cross.
No, because this says let's continue x to numbers bigger than 3. So just keep going as for all numbers bigger than 3.
Do you have to draw an open and closed dot?
Yes, you always have to have one open dot and one closed dot because that's where they link up.